All right. Welcome, everybody. Oh, you can't see me. That's no good. Let's add this in here. We got a new computer, so we got to set up OBS a little bit here. Yes, allowed. There we go. Make us nice and small. All right. Let's get to it. Okay, so I have been working on something for a little bit, and after WWDC, it seems like there's been a lot of folks that are getting really into a bunch of the changes and updates made in SwiftUI. I'm personally really excited for some of the multi-platform stuff, and I've been working on an app for a while, and I saw an app from someone that he's been working on, and I'm working on something similar, I guess you could say. But what really struck me about Paul's design here is his graphs, and in particular, I have a similar style of graph in my app, and what I want to talk about is how I basically made kind of a line chart that can both be drawn in a bunch of different sizes and ways. So you could support drawing it, in this bigger card, in this smaller card. I actually use it in a lot of different places, even smaller, if you've seen the iOS Stocks app. But the other thing I want to do with it is I want to animate it. Or I wanted to animate it. So I'm going to show you how we do that, or an example of how you can do that. So that's what we're going to take a look at tonight. So let's go ahead and do that. And the way that I approach this is I wanted to, again, be able to draw and give a list of points in terms of, say, the stock price to a view, and then I want it to draw the line in that view. And like I said, I want to be able to size it up, down, big or small. We want it to scale nicely, and at the end of the day, we also want to animate it. And we also want to be able to change the color, right? So one thing you'll notice, right, is if you look at the Apple Stocks app or this one, right, if the final price is lower than the starting price, for that day or for whatever time period you're looking at, the line graph changes colors. So we'll give this a shot and see what we can do. So first thing I'm going to do is I'm going to define a new shape. And so I'm going to call it, line graph view. And this is going to be a shape. Okay, so let's take a quick look. What is a shape? Just so people are a little familiar. So it's a 2D shape. Ooh, whoa, there we go. It's a 2D shape that you can use when drawing a view. And basically the benefit of shapes is that you can define the shapes in relation to an implicit frame of reference. So what that means is that when you build up your path or your shape and you give it to the framework to draw, it gives you a rect, or it gives an actual size that it's going to draw in. So this is going to help us actually make sure that when we draw our line, that it fits appropriately in the size that it's given. So that means you're going to have a really big graph, a really small graph, whatever size you want. And so this part is really important. So we're going to go back here. We do not conform, so we're going to add our stub. And so what we have to do here, right, we're just looking at the docs for this line graph. We have to return a path or a squiggly line, or our line graph in this function. Okay, and so if you think about it, right, we're going to get a rect. Again, right, this is like the thing that we're going to be drawing in, and we are then going to basically use those bounds as the bounding box for how we want to draw our path. And let's say that the stock was doing really well that day, and basically our bottom left-hand corner is where the stock started at the day, and then the top right-hand corner is where the stock ended. In that case, we would draw essentially just a line or a path from the bottom right-hand corner to the top left-hand corner. Okay. And now obviously stocks don't actually do that, they go up and down, but we'll take a look how to do this. So one thing though, my line graph view needs to take in or have a set of data points. And I'm going to ask the person using this to pass in a list of floats or CG floats. Can't find this in scope. Is this just Xcode being itself? Okay, all right, yeah, that was just Xcode being weird. Okay, so and what we're going to pass in here is actually going to be normalized points, and I'll show you why. So what I mean by normalized is basically if you have one stock, right, say Apple, and it starts at say 250 at the beginning of the day and it ends up at 275, or you have Microsoft and they're at say 200 and it ends up at 225, you don't want to have to deal with, or I don't want to have to or I don't want this view to have to deal with the math of kind of normalizing this. So what I'm expecting is for this to be translated where 250 is equal to 0 and 275 is equal to 1, and the prices in between throughout the day are going to be kind of interpolated between there, right? So that means the top of the graph is where the highest point it was at the day, and the bottom of the graph is the bottom of that point of the day, and that just makes our view logic slightly less, I guess, tied to the outside, whatever's being passed in, right? So this is basically normalized data points between 0 and 1.0, right? Okay. So when we draw our path, we are going to assume that we have more, we have points. Otherwise you could put like a guard statement here or something like that. But essentially what we're going to do is we're going to say, our starting point is going to be here. And we are going to oops. We are going to return path. Yeah. And we can clean this up a little bit. How do we want to do that? Yeah, okay. So we're going to return a path, and that's going to be in, and we're basically going to, start at a given point, and then we're going to move all up and down and around, and then basically add little lines between them, and then return that path. So, first we are going to move to point, and that point is essentially going to be 0 at the x, so we're starting at the very left. And now the y coordinate is essentially going to be, if you think about it, right, it's going to be, if we start up at the top, right, which is really 1, and then we subtract the distance, and then we multiply it by the height, we get where we need to go, right? So we our y is essentially going to be 1 minus the start times the height, and then basically what we're going to do is basically go through our data points, and we are going to basically add a line to the next point. And the next point is, let's do that, right? So what we need to do is we need to grab the next point and figure out basically how far to the right we need to go based on how many points we have, right? So, if you only have 10 points and your view is 100 wide, you only need to move over 1/10. But if you have 1,000, you have to move over a different point, right? So we will define a different function that will kind of figure out where the next point is to the right and where the next point is up. So we'll call this like next point at index. This is an integer, and we're going to return another CG point. Okay, so like I said, right, we have to figure out this point is meant to be how far over, which is essentially determined by how many points do we have divided by the width, and then the height, which is essentially the same thing we're doing down here, right, which is like how far up in the view, or how high is it between 0 and 1, right? So we basically need to say get our point, which is just the data points index, right? So the one that we were passed. And now we need to figure out the x and the y. So x is going to be, we don't have access to the rect, so we got to put this in here because I don't have access to the, I need this size and height. So this is essentially the width times essentially how far over, so how many points, right, divided by the number of points it is, right? So this is going to have to be that divided by the width, right? So this is now essentially, right, we have to say how many points do we have total to draw in a given width. So you know, like I said, again, if you have 100 points, you're moving over 1/100th of the width if you're moving, right? So, but if you have 10, you're not moving over that 4. So basically it's, you know, this point divided by the number of points times the width. So that's basically essentially like the data points number minus 1, right? So that's where we draw the next point to the right. Now we got to figure out the height. So the height is essentially starting at the top, you know, 1 minus the the actual value, right, between 1 and 0, times the height, right, because then you have to move it up based on the height. So this is really just 1 minus the point that we're drawing, right, or the value times rect dot height. Okay. And then we return CG points XY or something like that. Yeah, X is X and Y is Y. Okay. So now, right, we can draw a point to the next point at a given index, right? So this is basically just saying draw a line from the current point that we have to the next point, which is the next one in line, next one at the index, okay? Get my chat screen out of the way here. All right. So if we put this line graph view in the view here, let's see what we get. Okay, let's just do something silly here. We're basically going to say, you know, repeat CG float.0, right, for 10 points. Resume. And so this isn't really gonna fill, and we're gonna say what do we want to do? We want to do we got to give it a stroke. Yeah, that's what I was forgetting. We don't want to fill, we want to stroke. And we got to give it a style. Or we can really just give it a color. So let's give it color.green. And actually, let's make this a little more interesting. Let's do give me random data and return me an array of CG floats. we can steal this. 10 points. In 0 to 10 minus 1. Right. Actually, let's do this. Let's let someone pass in the size. Right. That way we can show, drawing a ton of points or drawing a few less points. And then, oh, my dog wants to join me. What's up, pup? Hey. Okay. So then we're just going to put each point in here, and we are going to make a float. And essentially, it's just going to be a random number between 0 and 1. Float.random. Float.random in, and let's do like 0.1 to 0.9, right? And then we'll return data. So this is going to get random data 10. Okay, so we have our graph. It's not pretty, but we have a graph. Let's zoom in here a little bit. Okay, so we have this, this box, right? And so this thing is taking up the whole view. And, again, essentially we have values between 0.1 and 0.9. So we would never go, below somewhere down here and above somewhere down here. Now, if we were to make this smaller or, bigger like this, right, we might see values that are closer and closer to the top and bottom, right? Because we're normalizing between 0 and 1. So let's go ahead and we will make the stroke a little bigger. So we'll give it let's give it a line width of 3. It's a little thicker. Oh. Font bigger. Yeah, that'd be a good idea. I have it bigger on my IntelliJ, but not on here. There we go. Whoa. There we go. That seems a little better. Although that's wonky. Does that really look right? Oh, that's not for everything. There we go. That's better. Okay. All right. So hopefully that's better for people to see. Okay. Now, let's take a look at what else we can do. So let's take a look and see what happens if we try and draw these in different sized views, right? So this is a view that's 100 by 100. And just to show this, I will do, oops, rounded, well, so I'll just do color dot gray, right? So again, part of what we were doing was we wanted the graph to draw at any given size or height, even if it was maybe you know, a rectangle or a square. So if we bump this down, right, you can see you can draw something a little smaller. You know, you can really crank this down, right, something like this, and it will still draw appropriately. And if you see, you know, this, right, so this allows you to have a really wide line that's really tall, right? So you could have something that's like 400 wide, right, or 300 wide, right, and, you know, a little shallower, but then you could also give yourself a little more room for some of the big blips, right, if you needed to. And similarly, like if you look at the Apple Stocks app, right, see if we can take a, see if you can see the picture of it. Yeah, right, so the Apple Stocks app, right, so this would allow you to draw both this line and this big line, right, with the same view, okay, with the same data. And it would just scale up or scale down. And again, because it's a path, you can then use the same view and draw whatever stroke you want on it, right? You can change this. So, and the other thing that you can do, right, is you can make this dynamic. So, for example, if you want to change your colors, right? So let's say you want your line to change, right? You can say color from data, and you know, say you gave it the starting value and the ending value of the stock, right? You could then say, you know, if start is greater than end, return one color, else return another, right? So, you know, here you could return green or red. And then color. So then what we can do is we can say base the color off of color from, and then basically this will be what, data dot first, yeah, so start will be self dot data dot first, and end is self dot data dot last, right? So then this will change the color of the stroke, color from data, right? So now this will oh, yeah, sure. We won't get hung up with that. So it'll just always be green by default. So we can, you know, keep refreshing this, right? And actually that looks, I think this is wrong, right? Yeah, that's better, right? And also too, you get the ability to draw tons of points or a lot of or a few points, right? So if you're showing, 1 day's worth of points, 5 days worth of points, a year's worth, whatever it is, you can draw graphs kind of at any size and get what you're looking for. Now, let's talk about animation. You can animate every time it moves a point, and the way that we're going to do that is we're going to basically set an animation. We're going to set it as, say, ease in and out, and we might do this with a duration, so we can slow it way down and check that out. And basically we're going to do it on appear. And so here's where this kind of trips people up. When you're doing something declarative, you can't say start. You have to essentially change a value from one to the other and get it to animate. So one of the things on shape is a method called trim. Okay, and basically trim is a way to say, this is how much of the path or the shape that you should draw. So trims this shape by a fractional amount based on its representation as a path. So this allows you to basically, so here, right, if you set your trim from 0 to 1, that means draw the whole thing. And because we're drawing from left to right, that means draw from the left and then draw to the right. Now, if you set the trim to 0.5, that means only draw the first half. Okay, so let's take a look at what that really means. So I'm going to set the trim to 0. And then what I'm going to do is in here, I'm going to set the trim oops, this takes a float. What am I missing? Label 2. So here, I'm going to set the trim to 1.0. On appear. Oh, I got to pull this out. Let trim equal 0.0. Right? And then I'm going to change the value to a different value. And because I have an animation set on here, this is going to animate that that change, right? Actually, I'm going to start this as that. Var. Okay. So again, going back to this declarative style, and this is state. Oops. This is state of the thing, right? So again, this is the declarative style that's a little tricky. Like people are usually used to saying like, start and stop animations or whatever. You really don't often do that in SwiftUI, and you essentially just want to say, I want to go from one place to another, or you say, if I'm here at 0, I want to now set my trim to 1, and then basically set some sort of animation. And SwiftUI will do, honestly, a lot of stuff by default for you, okay? So let's take a look and see what happens when we do this. So we're gonna hit play because this isn't gonna preview, right? Let's see how it's gonna draw. And so basically what's happening with the trim is that it's slowly moving over the course of 5 seconds from 0 to 1 and drawing the line. Okay. Now, if we set our duration down to 1, right, this will obviously change. So I'm going to stop it and rerun it again, right? Now it's going to draw a lot faster. Okay. And so you can control this, right? And you can say, you know, hey, repeat forever. So, you know, again, if you use the built-in primitives, the drawing primitives, paths, shapes, things like that, and you follow those, when it comes time to actually animate these things, you don't have to manage the animation yourself, right? All we're doing here is we initially had our line graph, and we drew the whole thing, and then on the shape itself, this trim function, right, just determines how much of the thing gets drawn in your path. And all we're doing is basically we're saying whenever the view appears, right, draw that view. And we're just saying, hey, rather than, you know, be at 0, draw yourself really at 1 and animate the difference between 0 and 1. So, and again, this works at any size. So if we make this bigger, right, that also animates, right? And that's just a matter of me doing that there, but it doesn't necessarily do that, right? But it illustrates the point, right? When you change values in Swift, that's what animates, right? And it animates automatically for you. Okay. So and we'll stop this here, right? We'll put this at a more reasonable height. Right, so that looks a little more reasonable. Let's do, say, 30 points, something like that. This is something that I did. There's a bunch of different ways to do it. I kind of like this. It lets me draw at all sorts of different sizes and shapes. You could just as easily do rounded corners and things like that. To make your graph look a little smoother rather than this super sharp version. But yeah, this is just something that I did in one of the side projects that I've been working on, and it's a really neat effect, and it demonstrates, right, the declarative nature of SwiftUI, right? You're kind of handing off a lot of control to the framework to say do something, and now you have full customization, right? You can give it whatever animation you want. We could change this animation to just be linear, and this animation is totally going to change how it draws, right? So now it just draws linearly over 5 seconds. So you can change everything about how it animates, but in terms of animation in a declarative world in SwiftUI is all about going from whatever value it's currently at or whatever value it's currently drawn at, right? Meaning 0 in this case. And we're saying, and literally by just setting a variable to 1, say, I want to go to here. And by having an animation on here, it will animate, from the value that it's at, and it will animate all of the values that you change, right? So not just this one. So in this case, I'm only evaluating the trim, but as you saw, if I change the height, it starts animating that one as well. So, yeah, so that's kind of all I wanted to kind of go through tonight. I might do some more of these in the future, but just little bite size of these things, right? As kind of I work on this project on the side. So I know that this is a little different coming from, not from a declarative world, but I promise, as you work more, whether it's SwiftUI, React, Jetpack Compose, any of those things, getting used to and understanding this declarative nature of things is really honestly changes UI programming in so many ways for the better. So it's all around it's all about modeling state rather than managing state, which is really cool. So that's it for this stream, I think. Let me know if you got any questions. I will share this code probably on GitHub, and I'll put a link in the YouTube video for it. But I think that's about it for tonight. So